Acute angle measure between 0 degrees and 90 degrees. Right angle measure exactly 90 degrees. Obtuse angle measure between 90 degrees and 180 degrees. Straight line measure exactly 180 degrees. The flat angle measure between 180 degrees and 360 degrees. Full circle measure exactly 360 degrees.
Okay, my turn is to present about radian. We often use degree to measure angle, however, we have another measurement of angle called radian. Instead of fitting the full circle 360 degrees, split into 2 pi radian. We must use radian in calculus, differentiation and integration, complex number and polar coordinate. May seem new and complicated at first, however, it is no different that we could measure length in meter. Okay, below we have a circle, full circle showing some angle in degree what they are in radian. Okay, example 30 degree. Same as 1/6 pi radian. Another 180 degree, same as pi radian. 120 degree, it's same to pi/3 radian. Another 270 degree, 3/2 pi radian. Uh, Lastly, 360 degree, same as 2 pi radian. Okay, how to convert between degree and radian? Okay, familiar to convert degree to radian. You can use x degree over 360 multiply 2 pi radian. Okay, that you can get answer in radian. Okay, that convert radian to degree. You can use x pi over 2 pi multiply 360 degrees. So you can get answer in degree.
Okay, now we will proceed to right angle triangle. So when we are given a right angle triangle like this triangle with one of the non-right triangles labeled theta, then we have to label the sides as follows. The longest side is called hypotenuse and the opposite side to the angle is opposite, and next to the angle is adjacent.
Now we move to the next subtopic in trigonometry, which is Pythagoras theorem. I'm sure that all of us had learned the Pythagoras theorem in school. As we know that Pythagoras theorem related only to right-angled triangles, which we learned previously. So, given a right-angled triangle such as the one below it states, this is the formula of Pythagoras theorem. C square equals to a square plus b square, which is a square is which is a is the vertical one, b is horizontal, and c is the hypotenuse. So to find the hypotenuse, c equals to square root of a square plus b square. Let's do this example. Find the value of x, y, and z in the following triangles. So now we'll look at the first triangle. Given the hypotenuse is 9, b is 7, and a is x. So we need to find the value of x. First, we write the formula of Pythagoras theorem and substitute the value in the formula. Then we need to solve it to find the x squared. So the answer is 81 minus 49 is 32. So x equals to 5.657. The second triangle, given the hypotenuse is 13, but the value of b is y, so we need to find y, and a is 8. So first, we need to substitute all the values and solve it to find the y square. Y square is 13 square minus 8 square. $105. So y equals to 10.247. The third triangle, we need to find the hypotenuse, which is z. So substitute all the values in the formula and solve it. So z square equals to 136. Oh my god. So z equals to 11. $11.662.
So the fifth subtopic in trigonometry is SOFIYYA, which is we had learned this in high school. So we just need to recap. So let's say we have this right angle triangle, and this is our angle theta. So basically, there are three sides of this triangle that we need to be familiar with, which is the first side is the opposite of the angle theta, we call it as opposite. The second side is next to the angle theta, and we call it as adjacent. And the third side is across the right angle of triangle, we call it as hypotenuse, which is hypotenuse is the longest side of this triangle. Okay, for the sine function, we define the sine as the ratio of the opposite to the hypotenuse. Sin theta equal to opposite divided by hypotenuse. And according to the SOFIYYA, the S in the SOF stands for sine, O stands for opposite, and H stands for hypotenuse. So it becomes opposite divided hypotenuse. Next, this is the graph of y equal to sin theta looks like. For cosine function, we define cosine as the ratio of the adjacent to the hypotenuse, which means cos theta equal to adjacent divided by hypotenuse. And C in ca stands for cosine, A stands for adjacent, and H stands for hypotenuse. And this is how the graph of y equal to cos theta looks like. And last but not least is tangent function, and we define the tangent as the ratio of the opposite to the adjacent, which means we can say that tan theta equal to opposite divided by adjacent, and we can also say that tan theta equal to sin theta divided by cos theta. So T in TOA stands for tangent, O stands for opposite, and A stands for adjacent. So this is how graph of y equal to tan theta looks like.
I will talk about inverse function and rearranging trigonometric function. What is the use of inverse function? we use inverse function to find the angle between the length of two sides of a right angle triangle given. Second, to rearrange an equation with a trigonometric function. The inverse function of sine sin is sin power of -1, also can be noted as arc sin. The inverse function of cosine cos is cos power of -1, also can be noted as arc cos. The inverse function of tangent tan is tan power of -1, also can be noted as arc tan. We use the inverse trigonometric function with SOHJATO to find the value of angle in right angle triangle with two of the lengths of the side has been given. As the example, by the triangle given, the hypotenuse is 11 and the adjacent is 6. So we have to use the cos. So cos t equal to 6 divided by 11. So we can use our calculator to find the cos power of -1 6 divided by 11. So we get the 56.9 degree or 0.99 radians. Note, when scoring trigonometric functions such as sin x power of 2, cos x power of 2, and tan x power of 2, we use the notation sin power of 2x for sin x power of 2, cos power of 2x, and tan power of 2x are used in the same way. This is also true more generally. For example, sin x power of n is denoted by sin power of n x.
In chemistry, chemists use trigonometry when accurately describing the angles that are created when atoms bond together to form molecules in molecular geometry. Trigonometric functions such as sine, cosine, and tangent are essential to describe materials in their three dimensions. Okay, now let's check out the example. First, molecules want to be as far away as possible from each other when they bond. Second, when molecules spread apart from one another, they create angles. Next, to find the measure of each angle, draw lines connecting each molecule to form a triangle. Triangle formed with carbon and two hydrogen atoms as vertices. And lastly, after creating a triangle, you can use trigonometry to accurately determine the measure of the angles.
Now we will look on some questions on trigonometry. So first one is missing length. Find the length of the side marked Y. This here. So how we solve this question is by firstly we need to identify the given info given. So we have an angle of 38 and we have a hypotenuse. So we can solve this by using SOHJATO and we use cos because because we want the info that we want is in the equation. So we just substitute the data given and we solve for the y and we got the length of the y. So we proceed to the next question. So BH is perpendicular to AC. Find the x length of the BC. Okay, so as we look here, if BH is perpendicular to AC, then it means that ABH and HBC are right triangles. So now firstly we look for AH. We use time and we substitute the angle and the opposite length, and we got the AH is 13.58. Next, so when we got the AH, we minus the AC, minus AH from the AC, and we got 5.42. So now we have HC and also we have BH. So now we can find for BC using Pythagoras theorem, and we solve for BC and we got the BC as 12.3 cm. Okay, so the next question is chemistry example. So the position of certain bands in the infrared spectrum of SO2 can be used to determine the angle of the whole SO bonds. The analysis leads to the equation. Okay, so now we look at this equation. Firstly, we see the square in scene, and we want to find the theta. So firstly, we square root both sides to remove the square on the scene. And now we take the inverse on both sides. And then we bring the 2 to the side, and then we get the theta.
The question here is, the carbon-carbon bond has length of 154 pm. If the bond is positioned at an angle of 30 degrees to a surface as shown in the picture, what is the projected length of the bond? We know that this is the right angle triangle, and therefore we can use the Socha-Towa formula. We know that the hypotenuse is 154 pm, and we want to find the projected length, which is the adjacent. So we can use the JUNAIDI formula, which is cos theta equal to adjacent over hypotenuse, where the theta is 30 degrees and the hypotenuse is 154 pm. So after we make a calculation, we can find A is equal to 77.3 pm. Therefore, the projected length equal to 77.3 pm, or approximately equal to 133 pm.
Look at this question. Below is the structure of solid potassium chloride. If the distance between the centers of adjacent chloride and potassium ions is 3 to 1 pm, what is the next shortest distance between such ions? Or what is the length of the red dashed line? We already have this cube lattice which contain ion chloride and ion potassium. Chloride is the black and potassium is the blue. We need to consider the triangle from the cube lattice above with lengths ABC. This is right angle triangle that contain length of A, B and C. This is right angle triangle that we can apply Pythagoras theorem. From the question, we know that the distance between adjacent chloride and potassium ions is 3 to 1 pm. Write the value. A equals to B equals to 3 to 1 pm. To find the hypotenuse or the value of C, we need to use Pythagoras theorem. So C square equals to 3 to 1 square plus 3 to 1 square. C equals to 454 pm. We consider the triangle from the cube lattice with length C, D and E. As the question asks us to find the value of this next after this shortest distance, which is E, the value of D, same as the A and B value. Right angle triangle, D equals to A and B. Since we just find the value of C, which is 454 pm, substitute it in theorem Pythagoras formula. 2, 5, 5, 6 pm. The answer of the red dashed line, which is the next shortest distance of the potassium ion and chloride ion, is 556 pm.